Hello friends, welcome to Kumba Science Academy. Today we will solve the exercise number 1.1 of Mathematics 2, chapter number 1, differentiation. Within this exercise we will apply the chain rule which we saw in earlier lecture. Now how exactly and how much we can apply, that's most important part of this topic. And these examples given in your exercise are for practice purpose, and therefore using exactly this, not exactly means using our appropriate methods, we can practice them. So most important part is what? Here we need to concentrate on our differentiation process. Step by step we will perform it, but most important part another is there are two types of methods which shown in book, and where you can consider the variables, and again we need to put them in our equation, and one is directly differentiating the given equation. So most of the students like direct differentiation, and exactly that is easy, but most of the students are doing it step by step. Okay, as per the part of confusion, to reduce that confusion and to get a proper answer, if we use the substitution method, then that will be helpful. If you use the direct differentiation process, that requires so much practice. So we will focus on exactly how we can solve it by using our substitution and by using our direct differentiation method. Okay, so let's start. So exercise number 1.1 of differentiation, of which we are taking first question. So question number 1 of what? The question number 1 we are taking first. So let y is equal to, okay, so whenever you are solving this question, so you need to start with like this, let y is equal to, because the given function over there, it don't have any kind of indication whether it is y or x, y, z, anything like that. So they have given us only that quantity. Now we need to consider it. So therefore let y is equal to this much. Again in bracket, what is that quantity? X cube minus 2x minus 1 bracket raised to 5, x cube minus 2x minus 1 bracket raised to 5. Now here the method 1 says that, okay, so we will look at the method 1. Here what we can do, we can consider this whole equation as u, okay, and then afterwards we can simplify it. So for doing this first method, differentiating both sides with respect to x, what will happen? Dy upon dx is equal to d upon dx of x cube minus 2x minus 1 bracket raised to 5. Now here let u is equal to x cube minus 2x minus 1 bracket raised to 5, sorry not 5, only this much. So within this bracket, whatever the quantity we have considered as a u, therefore the equation will become dy upon dx is equal to d upon dx of what? U raised to 5. Okay, now next important part is what? So up to this everything looks fine. So next step is dy, this was actually equals to dy upon du dot du upon dx. Understood? Hope you understood. Now most important part, so this we have over here, so we are differentiating with respect to x, and we got this step by step. Now here what we need to do, we need to simplify it using what? By using chain rule. So this is what? Chain rule. Okay, so this is nothing but chain rule, and using this chain rule we can simplify it. Most important part is our given equation is in this form. Okay, now this is the answer which we are seeking, okay, which we are about to find out. But before finding the answer, let's look at these complications. I'm doing it step by step, that's how it looks complicated. Okay, I'm doing it step by step. So what is the value of this y is nothing but u raised to 5. Again, that y differentiate should be with respect to u, and again that u should differentiate with respect to x. Therefore, I am doing all this stuff. Okay, this looks sometimes complicated, but step by step we need to find out what is dy upon du. So again, therefore dy upon du is equal to d upon du of u raised to 5, which is equal to 5 u raised to 4. Okay, this is again important equation. So what should be this equation? This equation should be first, second, third, no, second. So here is the first equation, equation number 1. This is equation number 2. Next step, du upon dx, which is equal to d upon dx of x cube minus 2x minus 1. Hope this is correct? Yes, correct. Now we need to differentiate, and we can differentiate directly. So what you will get? 3x square minus 2 minus 0, which is not required. So you can have this value. Now again substitute this equation number 2 and equation number 3 in equation number 1. So by what? Equation 2 and 3 in equation 1. Okay, so on that basis we can again have our values. So substitute it, just look at this quantity. So dy upon dx is equal to, what is dy upon du? dy upon du is nothing but 5u raised to 4 dot, what is du upon dx is nothing but 3x square minus 2. Now again, what is the value of u? U is nothing but x, where is that u? Here, x cube minus 2x minus 1 dot 3x square minus 2. Look at it properly, how simplified it is. Wait a second, the 4 I missed. Yes, 4 should be here. Okay, so this was method 1 to simply solve this kind of questions. Okay, so hope you got this question. Now if I want to differentiate directly, so that is the method number 2. Okay, so hope you got the method 1. Now whenever you are performing, if you are at beginner level, so all the 11 and 12 standard students are in initial stage, so I would like to suggest you to do it in this way. Okay, to solve these problems, if you get it properly, then only you can try it directly. But if you are not able to solve these problems in this method, so that might be complicated. So most of the teachers are teaching this kind of problems and they are solving those questions directly. Okay, why? Because they feel it is easy, and students also feels that that is easy process. But when it comes to the complicated cases, then you might get wondered, okay, how exactly we can arrange the things. So that's why I am solving this problem step by step. Okay, so next problem is something like this. So now we need to solve it directly. So this was method number 1. Now let's move to the method 2. So method 2 says something like this. Okay, so differentiating both sides, that's the common statement. Differentiating both sides with respect to x, what will happen? Dy upon dx is equal to what? Dy upon dx is equal to, so this whole quantity we will consider as a 1, means u, and again differentiating. So what is the f of x over here? So f of x raised to 5. So f of x raised to 5 means how much? So there is differentiation. Okay, so d upon dx, I would like to write it properly first. So x cube minus 2x minus 1 bracket raised to 5. The f of x raised to how much? 5. So let's take that 5 over here. So n into f of x is what? 3x cube minus 2x minus 1 raised to 4. Okay, after this process everything is correct. Now what is the differentiation of this? Okay, you need to do it thoroughly, otherwise d upon dx of x cube minus 2x minus 1. Okay, as we had this formula earlier, the f of x, okay, the differentiation of f of x dot derivative of f of x. Okay, so again we need to differentiate it once. Okay, so finally what you will get? 5x cube minus 2x minus 1 bracket raised to 4. Now what should be its derivative? So 3x square minus 2, that's it. That's our final answer. So within 3 steps we can solve this problem. But if you are at beginner stage, if you are doing it first time, so I would like to suggest you method 1, okay, which is step by step we can get the answer, and the chances of getting wrong are less. Okay, good. Now next problem is I am doing it by method 1. Okay, so I would like to erase this from this space. Okay, now next problem is what? Question number 2. So question number 2 says something like this: let y is equal to, in bracket, what are the quantities are given? 2x raised to 3 by 2, 2x raised to 3 by 2 plus, so minus 3x raised to 3 by 4, no, 4 by 3, 4 by 3 minus how much? 5 bracket raised to, again how much? 5 by 2. Okay, again for this, if you are doing this problem with method 1, okay, that will be fine. If you are doing it directly, then that's the most easiest way. So differentiate both sides with respect to x. Okay, next step, differentiating both sides with respect to x, what will happen? Dy upon dx is equal to d upon dx of 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 bracket raised to 5 by 2. Okay, so quite difficult to understand how exactly these terms are changing. Now let u is equal to 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5. Okay, now next step, what is the next step? So therefore equation will become, so dy upon dx is equal to how much? D upon dx of u raised to 5 by 2. Okay, now next step, which is again equal to d u raised to 5 by 2 divided by du dot du divided by dx by chain rule. Equation number 1. Okay, next step. Now substitute the values. So what we need to do first, we need to differentiate it. Okay, so therefore d upon du of u raised to 5 by 2, which is equal to 5 by 2 raised to u raised to 5 by 2 minus 1. So 5 by 2 minus 1, how much? 3 by 2. So this will be 3 by 2. Okay, okay. Now next step, and I would like to write and du upon dx, which is equal to how much? D upon dx of 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5. Okay, okay, everything looks fine. Now next step. Now if you differentiate it, what you will get? So 3 by 2, so 2 into 3 by 2, 2 will get cancelled, into x raised to 3 by 2 minus 1, how much? 3 by 2 minus 1 will be 1 by 2. So 1 by 2 minus, now again 3 by 2 common, so 4 into x raised to 4 by 3 minus 1, how much? 1 by 3 minus 0, so no need to put it. So finally here we are getting what? Okay, so I will write it neatly. So 3x raised to 1 by 2 minus 4x raised to 1 by 3. So this is what the du upon dx. Again substitute these equations. So what you will get? Dy upon dx is equal to, substituting it, what you will get? 5 by 2. What is the value of u? U's value is nothing but 2 x raised to 3 by 2 minus 3 x raised to 4 by 3 minus 5 raised to 5 by 2 dot, in bracket what is this? 3 x raised to 1 by 2 minus 4 x raised to 1 by 3. That's what our final answer is. So that's how we are getting this dy upon dx. Okay, hope you got it. As you can check the answer, okay, this much is sufficient. Now here they have used some symbols. Okay, so as I told you, the symbols are simply meaning of something. Okay, so 1 by 2 has this, so I would like to again repeat it. X is equal to how much? X raised to 1 by 2, and 3 under root of x is equal to x raised to 1 by 3. 4 fourth root of x is equal to x raised to 1 by 4. Okay, you can see this. Okay, you can see this. And 5 root of x is equal to x raised to 1 by 5, and so on. Nth root of x is equal to how much? X raised to 1 by n. Okay, this was the important parameter. Okay, so using this, okay, you can simplify your question and you can match with your previous answer. Now next step, the next problem. Okay, again we need to differentiate this next problem. The question number 3 is easy, so hope you can do it. Now move to the question number 4 of question number 1st, which looks complicated to me. Don't know what's about you. So hope you are getting this question. So using method 1 I am solving. I can perform it directly. Okay, for you only we need to perform this step by step. Okay, for few problems just perform these problems step by step. Okay, afterwards once you get used to it, you will definitely solve these problems directly, and afterwards we require such kind of thing because we don't have that much time to solve it step by step. Okay, so we need to be adopted this type. So fourth question I would like to take. The fourth question says something like this. What is that? Let y is equal to how much? Y is equal to under root of x square. Okay, under root of x square plus under root of x square plus 1 x square plus under root of x square plus 1. Very very interesting problem. Okay, look at it properly. What we need to do, we need to just simplify it. How, sir? Because this is the whole function which is in under root. Again it has some function which is in under root. Okay, so don't worry about it. So what we need to do, we need to put, or no, we need to directly differentiate. So method, using method number 1. So method 1, I am saying it direct. So differentiating both sides. See, here we will solving it. So differentiating both sides with respect to x. What will happen? Differentiating both sides with respect to x, simply d upon dx of y is equal to d upon dx of under root x square plus under root of x square plus 1. Okay, now to this step everything looks fine. Next step, let u is equal to x square plus under root of x square plus 1. Now this requires some skill. If you differentiate, so what is du upon dx? I am doing it directly. Du upon dx is what? 2x plus 1 upon 2 under root x square plus 1 into derivative of x square is nothing but 2x. This 2 will get cancelled. So at least for this step I am doing it directly, and again I will substitute within this bracket. Okay, so you could have this thing is how you can do it directly over here and why you are not solving directly over here. Okay, to make it simple I would need to simplify it first, but for each and every step we cannot do it step by step. Understood? So for this kind of step I am doing directly. So substitute the values. So 2x plus x upon under root of x square plus 1. What was that? That formula regards to this was, okay, so d upon dx of under root of f of x says something like this. What? F dash of x divided by 2 under root of f of x. Hope I am correct. So I am applying that formula over here directly, and that's how I am getting 2x over here. Okay, so don't forget to again differentiate this quantity. Okay, that's the most important part of differentiation. Now next step, simplifying it, we can see how quantities are working. Now I would like to put it like this only. Okay, that's it. The next step, what is the next step? So we have this with us. Now differentiating the both sides. So again this was equation number 1, this was equation number 2. Now dy upon dx. So we know dy upon dx is nothing but du upon u raised to how much? So what is the value of u? u raised to 1 by 2 divided by x, which is equal to u raised to 1 by 2 upon du dot du upon dx by chain rule. Okay, hope you got it. Next step, sir, why we are getting this all step by step? Okay, for few problems afterwards I will do it directly. Okay, so I will explain this problem. I will again perform direct method. Okay, so at that time you will understand how exactly we can apply that. Next step, nowadays people are like shortcuts, so they are liking shortcuts, so I would like to provide them. So but again you need to practice it. So this will equal to what? So du upon dx is nothing but half of u raised to how much? So this again using this formula. Okay, using this formula, what we can write over here? So this is nothing but, what is the derivative of u? Use derivative twice. So again we need to put it back over there. So u raised to half. So half is over here. Again u raised to Half minus 1 means what? Minus half. Okay, okay. Dot. What is this? Du upon dx. So du upon dx is nothing but our this quantity. So 2 whole bracket 2x plus x upon under root x square plus 1. Again, what is the u value? U value is very interesting. What is that? X square plus under root of x square plus 1. So 1 by 2. Okay, so that will be equal to 1 upon under root of x square under root of x square plus 1 into, I would like to take this 2x common. So once we take this 2x common, here what we will have 1 plus what? 1 upon under root of x square plus 1. Okay. So till which step we need to simplify it? So we need to simplify it properly. So here we will get 2. Okay, common. So again, simplifying this quantity, what you will get, this 2 will get cancelled. So x upon, if we multiply it over here, so making like base, we can move further. X into under root of x square plus 1, okay, into what will happen, 2 under root of x square plus 1 divided by how much? 2 under root of x square plus 1. Again simplify this quantity. What is that? So 2 only x into how much? X into 2 under root of x square plus 1, okay, plus 1 divided by 2 under root of x square plus 1 into under root of x square plus under root of x square plus 1. Okay, that's what the final answer is. Hope up to this point you are getting each and every term. So this was our final answer. Okay, up to this we can stop. So as I told you earlier, for this calculus purpose, up to which point we need to stop? We need to stop until our term will get simplified form. Okay, that compressed form. Okay, so up to that we can stop. Now let's move how exactly we can solve this problem directly. Okay, so see, everything looks fine up to this. So first we need to differentiate few quantities, then we need to differentiate once again, and step by step we can get the answer. So direct method, most of the students are like, they are liking this direct method. So differentiating both sides. So differentiating both sides with respect to x. That's how we will get dy upon dx, which is quite equals to what again? This d upon dx of under root of x square plus under root of x square plus 1. Okay, now what is the first derivative differentiation? So 1 upon 2 under root of x square plus under root of x square plus 1. Now next step, derivative of this is nothing but 2x plus 2x upon 2 times under root of x square plus 1. Okay, that's it. That's what we need to do. So again, taking 2x common and again simplifying this, you will get simple quantity. What was that? X into 2 under root of x square plus 1 divided by how much? 2 under root of x square plus 1, okay, into again under root of x square plus under root of x square plus 1. And that's what we required. Okay, that's our final answer. So within 3 steps we can get the answer. So that's the way of this concept. Now let's move to the question number 5. So question number 5 says that Okay, so hope you are getting all these concepts. So these problems are quite unique. Again, we need to solve them for practice purpose. Few means within these questions they will not ask. From question number 2 there might be chance of they will put some problems for 1 mark. So these are the 1 marks problems. Okay, now our next question is question number 5. What is question number 5? Within out of the question number first, the 3 upon, so let y is equal to 3 upon 5 raised to 3 root of 2x square minus 7x to x square minus 7x minus how much? 5 bracket raised to 5. So this is the question, okay, which they are asking us. Now let differentiate both sides. So I will solve this question by direct method. Okay, so how to solve by direct method? Just look at properly. Differentiating both sides with respect to x. What will happen? Dy upon dx is equal to d upon dx of 3 upon 5 raised to 3 root of 2x square minus 7x minus 5 bracket raised to 5. Okay, now this is equals to what? So this 3 and 5 raised to 3 are constant, so take them out of the box, and so 3 upon 5 raised to 3 is constant. Again we need to differentiate this 1 upon root of this whole quantity. So simply this is nothing but d upon dx of bracket complete. How much? 2x square minus 7x minus 5 bracket raised to how much? Okay, so bracket raised to minus 5 by 2. Okay, so how, sir, exactly this bracket raised to minus 5 by 2? Because I would like to give you one solution. So under root of x raised to 5, which is nothing but 1 upon x raised to 5 by 2, which is nothing but x raised to minus 5 by 2. Hope you are getting. So in that manner we can take this as, okay, so x raised to minus 5 by 2. Now our next step says that differentiating this quantity you will get, so 3 upon, so this is f of x raised to how much? Minus 5 by 2. So this 5 raised to 3 over here into minus 5 by 2 comes here into what is this f of x? 2x square minus 7x minus 5 raised to minus 5 by 2 raised to, sorry, minus 5 by 2 minus 1. So that will converts to what? Minus 7 by 2 dot d upon dx of what? 2x square means what? F of x minus 7x minus 5. Very simple. Just you need to be clear in your mindset that exactly what you are doing. So this is what? Minus 7 by 2. Hope you understood how exactly that minus 7 by 2, because minus 5 by 2 minus 1, which is equal to minus 5 minus 2 divided by 2, which is equal to minus 7 by 2, and that's how I came to this conclusion. Now I will solve it directly. So this 5 and this 3 means what? 2 remains. So 5 raised to 2 5 raised to 2 into this minus 2 will be written as 3 divided by minus 3 divided by 50 into, okay, the solving this you will get this much. Now again this remains as it is, but this is in downward term, so this is in inverse term. What is that? 2x square minus 7x minus 5 bracket raised to 7 by 2 into, what is the derivative of this 2x square? Will be 4x minus 7. Okay, that's it. That's our final answer. So again simplifying this, we will get how much? So minus 3 will be there. So minus 3 into 4x minus 7 divided by 50 into under root of this 2x square minus 7x minus 5 bracket raised to 7. Hope you understood this term. So therefore we are getting dy upon dx is equal to this much. So that's how we can solve this kind of questions directly. Just look at it properly once. Okay, hope you will understand. Now let's move to the next question. What is our next question? Next question is question number 6, which is again very similar to our initial problems, but we need to do it directly. Okay, so this was the direct method. We need this kind of fundamentals. Okay, that's it. And other new quantities which we are learned within this pattern. Now next question is what? Our let y is equal to, okay, so I will just erase this side, this much, okay. Now, and this one, okay. So what is this term? So root of, how much that is? Root 3x minus 5, okay, correct, minus 1 upon root 3x minus 5 bracket raised to how much? Whole 5. Okay. Now differentiating both sides, same thing we need to apply over here. So d upon dx of y, which is equal to d upon dx of this under root of 3x minus 5. Okay, again minus 1 upon under root of 3x minus 5 bracket raised to 5. Now this is the whole function we need to consider. Now if you consider though, what will happen? So 5 under root of 3x minus 5 minus 1 upon under root of 3x minus 5 bracket complete bracket raised to 4 dot d upon dx of under root of 3x minus 5. Okay, hope you will get it. Under root of again 3x minus 5. Now very interesting step. Now this step is clear. Okay, done. So this was f of x raised to 5. Therefore 5 is common after differentiating. So 5 into f of x into raised to 4. Okay, done. Next step. What is our next step? So 5 into, so if I rationalize it in terms of that, so I would like to get it in this way. So 3x minus 5 minus 1 divided by under root of 3x minus 5 bracket raised to 4 dot, what should be the derivative of this? Again the derivative of this will be like, so first we need to differentiate, again we need to differentiate this. So if you differentiate this, what will happen? 1 upon 2 under root of 3x minus 5, most important case. Again what is the derivative of 3x minus 5? Will be 3. Okay, done. Now bracket, we need to put minus, what should be the derivative of this? Minus 1 upon how much? So minus now. So the minus 1 upon 2 will be here, and this is the derivative of this will be what? 3x minus 5 bracket raised to how much? Minus 1 by 2 minus 1. Okay, again the derivative of 3x minus 5 will be 3. That's it. Again simplify this bracket, we will get 5. So what is 3 minus 5 minus 1? That will be 6 minus 6. So 3x minus 6 divided by under root of 3x minus 5. Okay, done. Now next step, again we need to simplify this also. What will happen to this? So this 3 by 2 remains as it is, 3 by 2 under root of 3x minus 5. Okay, done up to this step. Now multiply this minus sign over here, this will be plus, so 1 upon 2. So 1 upon 2, so means what? 3 by 2. I am taking this 3 by 2. Understood? Good. Now next step, what is this? Okay, this is nothing but minus 3 by 2. So minus 3 by 2 will leads to this 1 upon under root of 3x minus 5 bracket cube. Okay, done. Let's see whether we are correct or wrong. So answer for the question number first. After that we are solving this question. So hope this was correct one. Okay, if you solve it, okay, again further we need to simplify it. So here is what? Raised to this much. Again here we need to raise the power. So how we can raise the power? So this we need to look at it properly. We need to multiply and divide by some quantity. What should be that quantity that we are multiplying and dividing? So if you multiply over here by 3x minus 5, we will simplify it, or we can simplify it. Just take this 3 by 2 common. So therefore dy upon dx is equal to 15 by 2. Okay, so here what we are getting for this bracket. Okay, for this bracket I am thinking only. So under root of 3, this is under root of x. Okay, so I would like to make it simple. So under root of x minus or minus plus 1 upon under root of x cube. So what should be his final answer? So we need to multiply within this bracket. So if we multiply and divide by something, so what should be that quantity? That is simple one. Okay, what is that? X divided by this quantity will leads to what? X into under root x. Okay, so this x into under root x is nothing but under root of x cube plus 1 upon under root of x cube, and that's how we are making it like base. Similarly, I would like to apply this quantity over here. So this will be like 3x minus 5 divided by root of 3x minus 5 bracket cube plus 1 upon under root of 3x minus 5 bracket cube. Okay, done. Now next step, what is that? This was the remaining quantity. So I am taking it in simplified form. So 3x minus 6 divided by under root of 3x minus 5. Okay, done. Now again we need to simplify this. So again the common base, common factors, and on that basis what we will get? 15 upon 2 into what? Again simplify them. What should be the simplification? Plus 1 na? Yes, correct, plus 1. So what should be the simplification? 3x minus 4 divided by 3x minus 5 bracket raised to 3 by 2, done, into, again this is nothing but this quantity, within this quantity. So we raised to 4, it should be raised to 4. So this quantity is nothing but this quantity. So again we need to substitute those values. Okay, and then we can calculate it. Okay, so on this basis I have done this, and here this quantity I need to put. But the lack of space, I need to erase this thing. Again simplify it. Hope you are getting these complicated quantities. So under root of 3x minus 5 minus 1 upon under root of 3x minus 5 bracket raised to 4, and that should be your final answer. Okay, and okay, that's they have given us. So sir, this is correct or this is correct? Both are correct. Our work were done here only. Okay, this was our final answer. Up to this differentiation part, so everything we took common, simplified it, and that's how we are getting the answer. Hope you will enjoy this direct method. Okay, up to this polynomial terms everything was looking quite messy. So after trigonometric term you will find this is quite interesting. Now question number 2 says that differentiate the followings with respect to x. Now next terms are quite easy. Hope you are getting this quantity. Now let's move to the question number 2, out of which we are solving first question. So these questions are again having their own strength, so we need to be careful how we are handling these questions. Okay. The only thing is we need to be patient, and how exactly we are solving this question depending on that. Okay. If you do not have enough patience, definitely our answer will be wrong. Okay. So don't be in a hurry. Just make some steps properly. Now next step, question number first, cos x square plus a square. Okay, now what I need to do, I need to consider it. So let y is equal to cos of x square plus a square. Okay, so I am considering it. So possibly you will just write it like this. Okay, so differentiating both sides, for that purpose I need to put it like this. Okay, otherwise if I simply say that the different derivative of the cos x square plus a square is equal to this, that's not the possible case. So I need to first of all consider it. Most of the students are doing this, but they don't know why they are doing that term. Why? Because we need to just consider it and then we need to differentiate it. So differentiating both sides with respect to x. So you people are smart. So let's see, dy upon dx is equal to d upon dx of cos x square plus a square. Okay, now what should be our next step? Now this cos derivative is nothing but minus sine. Okay, the cos derivative is sine, so f of x will remain as it is. So x square plus a square, again the derivative of this f of x will be like this. What? X square plus a square. So what is the derivative of this? Minus sine of x square plus a square dot, what is the derivative of this? Okay, this is nothing but 2x and derivative of a square will be 0. Okay, so this is nothing but minus 2x sine x square plus a square. Now sir, where we are applying these things? So obviously these things we will see in physics. Okay, most important part, physics. The calculus is most probably used up to 70 to 80%. Okay, in physics. Afterwards this kind of equations, so differential equations are used in economics and the other variation purposes. Okay, so governing dynamics, most important word I am using, the dynamics. Dynamics, where there is a dynamics or the variation in variables and where there is a study of variation, at that time we use this differentiation. Okay, so I am giving you this additional knowledge where we are using this in dynamics. So the dynamics is related to the variable quantities. Okay, so variable quantities will lead us to particular conclusion. So variation of one quantity with respect to the other quantity, at that time we require this differentiation process. Okay, to find out at which point which kind of variation or which kind of growth is there. So at that time we require this kind of differentiation. But wherever there is a sinusoidal function and we need to differentiate it, so at that time also we can use differentiation, and that's how this differentiation process or the part of the calculus is so applicable. Now let's move to the next question. Hope this is our final answer, or you can write it as a d upon dx of cos x square plus a square is equal to minus 2x sine x square plus a square. Okay, we can write it like this also, and we can write it like this also, because we are initially considered that y is equal to what? Cos of x square plus a square. Okay. Now next question. What is that? Next question says that the under root of e raised to 3x plus 2 plus 5. Okay. So I will erase this side. Okay. So that will be in front of you. Now what is our next question? Question number 2 is under root of, let y is equal to, most important part, let y is equal to under root of e raised to 3x plus 2. 3x plus 2 plus 5. Okay. Now again do it step by step. Means directly we are differentiating. So okay, as you can see over here. So differentiating both sides. Differentiating both sides with respect to x. What you will get? So differentiating both sides with respect to x, we will get dy upon dx is equal to d upon dx of under root. Okay, so I would like to make this under root like this: e raised to 3x plus 2 plus 5 whole bracket raised to 1 by 2. What? This makes some kind of easy step. Okay, so this is the easy step where we can see that this power is nothing but 1 by 2. So we can take that as a n, and that will be like 1 by 2 into, what is this f of x? E raised to 3x plus 2. Look at this properly, plus 5. Again power will be this 1 by 2 minus 1 will be minus 1 by 2. Okay, 1 by 2 minus 1 will be 1 by 2 minus 1 by 2 dot d upon dx of e raised to 3x plus 2 plus 5. Okay. Okay. Now next step, what should be our next step? We need to again differentiate this whole quantity. Now it is simple, but we need to look at it properly. Okay, so e raised to 3x plus 2 plus 5. Okay, so this is nothing but this term dot, what is the derivative of this e raised to 3x plus 2? Is nothing but e raised to 3x plus 2 dot d upon dx of 3x plus 2 dot, sorry, not dot, plus derivative of 5 will be 0. Hope you understood. Okay, what exactly we are doing. Now next step, 1 upon 2, 1 upon under root of e raised to 3x plus 2 plus 5. Okay, next step dot, what is the next step? So this 3x is nothing but the derivative of this will be 3. So 3 into e raised to 3x plus 2. Just look at it properly. Am I right or wrong? Yes, correct. Right. Next step will be, what is that? 1 upon 2 means what? 3 by 2 into e raised to 3x plus 2 divided by under root of e raised to 3x plus 2 plus 5. Okay, just look at it. Whether our answer is correct or wrong? Yes, our answer is correct. Correct. No issue. Next step. Or what is our question number? Second. So within the question number second, we solved up to what? Question number 3. As you can see how these complicated are. These examples are quite lengthy. Okay, they looks easy but they are lengthy. So we will go to question number 3 or question number 2. Okay, so what says it? Okay, it says something very interesting quantity. Okay, log of. I like log so much. Okay, why? Because it bends that exponential graph to the linear one. Okay, टेढ़े को सीधा कर देता है. So that log, most important thing. Okay, so let this third, let y is equal to how much? Log of tan of, we know something, tan of x by 2. This is simple question, x by 2. Okay, I will complete this bracket. Now next step, differentiating both sides. So differentiating both sides with respect to x. What you will get? So dy upon dx is equal to d upon dx of log of what? Tan of what? X by 2. Okay, no issue. Now just consider it like this: log of f of x. What is log of f of x? Derivative 1 upon f of x means what? Tan of x by 2. Okay, good. Now next step, d upon dx. So f of x derivative again in multiplication. So tan x by 2. Okay. So what is the derivative of tan x? Is nothing but sec square x. Okay, good. So what is the derivative of that? Sec square x by 2 divided by tan x by 2. Okay, okay. Now into d upon dx of x by 2. What is d upon dx of x by 2? Is nothing but 1 by 2. So therefore this 1 by 2 dot sec square x by 2 divided by tan x by 2. Okay, is there any further simplification? Just check it once, we will find it. Okay, so how we got this answer? No, not yet. So sec square x by 2 is nothing but, there is furthermore expansion. What is that? Simplification. So what is that? So sec square x by 2 is nothing but how much? 1 upon sine. Yes, am I right? Just check it whether it is correct or not. It's not sine, it's cos square x by 2. Yes, sure. Divided by, so this 1, sorry, this should be 2. Again 2 sine x by 2 divided by cos x by 2. I am putting each and every quantity step by step. Okay, so दुश्मन का दुश्मन दोस्त, so this will be in multiplication. Again दोस्त का दुश्मन, so this will, and this quantity will get cancelled, remains what? 1 upon sin x by 2. So 1 upon sin x by 2 is nothing but cosec x by 2. So 1 half of cosec x by 2. Okay, so this is our final answer. As you can see, we need to just simplify this term to get the answer, and this is what we can do. Okay, after this step we can simplify. Okay, hope you are getting this term. Okay, done. Our next question. Our next question is under root of tan x. So tan under root x. So let y is equal to, I will do it like this. Okay, so I will erase all these things and just fill in blank. Okay, this, use this side like this, so it will help me. So y, let y is equal to, question number 4th, hope so. Question number 4 says that under root of tan under root x. Again differentiating both sides with respect to this. So tan under root of x bracket raised to 1 by 2, which is equal to 1 by 2 tan under root of x raised to how much? Minus 1 by 2. That's it. Dot d upon dx of tan under root of x. So what is the tan derivative? Is again 1 by 2 sec square under root x divided by tan whole under root term under root of x dot, what is the derivative of this under root x? Under root x is nothing but 1 upon 2 under root x. That's it. Just multiply it properly and take it common. So 1 upon 4 sec square under root x divided by under root x under root of tan under root x. That's our final answer. Okay, hope you got it. Now let's move to our next question. Now what is that next question? Next question says something like this. Question number 5th, which is quite interesting. Question number 5th is, okay, so I am just erasing all this stuff. Okay, so we can fill in blanks. Now next step, our next question, most important one, very interesting one. Okay, now question is cot cube x. Okay, so cot cube of log of x cube, cot cube of log of x cube. Okay, very interesting. Now differentiating both sides, what you will get, differentiating both sides, we will get dy upon dx of cot cube of log of x cube. Okay, now what is the derivative of cot? Okay, now instead of derivative of cot, here it is looking like this, d upon dx of cot log of x cube bracket complete cube. So this is f of x cube. So again f of x derivative, f of x bracket raised to 3 is derivative will be 3. F of x is what? Cot log of x cube, okay, raised to 2. Again derivative of this, what? Cot log of x cube will be, so the square, again I will move it to this bracket, within the bracket. So this let cot log of x cube derivative. Okay, so what is the derivative of cot? Cot's derivative is nothing but minus cosec square. Okay, so that is nothing but minus 3. This will be like cot square x. So cot square log of x cube. Okay, next step, what is the derivative of cot? Will be cosec square log of x cube. Now what is the derivative of log of x cube? So log of x cube will be like this. Okay, up to this step, hope you are getting each and every step. Now next step is what? What is the derivative of x cube? Okay, so I would like to do one simple step within this concept, is that the 3 comes over here and again gets common. Okay, hope you don't have any kind of problem to this. Okay, so let's see whether it will work or not. Otherwise we need to differentiate in our own terms. So this minus 3 cot square log of x cube, again this is cosec square log of x cube. This derivative will be 1 upon x cube dot d upon dx of x cube. Hope again we need to differentiate that. So once we differentiate it, what you will get? Minus 3 cot square log of x cube into cosec square log of x cube. Okay, so I am not using any kind of identity for this bracket. This bracket is consisting of one another property. What is that property? Cosec square x is equal to cot square x plus 1. Okay, so we had this property of this cosec square x, so we can use it, but I am not using because it will again create some mess. So I would like to make you focus towards this part, so that's why I am leaving it. So again, what is the derivative of this? Will be 3x square divided by x cube. This square and this will get cancelled. Okay, so remains out of 3 upon x. So simplifying it once, we will get final answer of this question will be, okay, so each and every step I have put in front of you. Now what should be the next final step will be, so dy upon dx is equal to, not final but tentatively towards the final, so 9. So this 3 into this 3 will be 9. Again, what is this? As I told you, to apply that identity, that identity would be like this, cot square. So what is the property of this cot? Cot is related to what? So cot square, if you apply, I don't think so we need to apply, just leave it like that only, otherwise it again creates some messy thing. So cot square log of x cube into cosec square log of x cube, okay, divided by whole thing divided by x only. That's it. That should be our final answer, and that's it is, yes, it is the final answer. Now this was regarding question number 5th or question number 2. Okay, now let's move to the question number 6th. So I am solving each and every problem. Hope I am also expecting from you that please do solve all these problems on your own. Okay, so question number 5th is done. 6th, this was question number 5th. Now what is 6th? Let y is equal to 5 raised to sine, how much? Sine cube of x, sine cube of x plus 3. Hope again differentiate. Okay, so this plus 3 is in the power. Okay, so I need to put bracket over here. Now differentiating both sides, what you will get? Differentiating both sides, what is the possible case? With respect to x, we will have dy upon dx is equal to d upon dx of 5 raised to sine cube x plus 3, bracket complete, done. Okay, so look at this, how exactly I am putting these brackets. So this bracket will give you the specific look towards the problem, so always use bracket specifically. Okay, so this is not the sine x plus 3, so this is not like this. So this is what? Sine x, okay, plus 3, okay, it's not like this. It is only sine cube of x plus 3, okay, that is separate form, so don't get messed with this x plus 3. Okay, so this is not like this, as I told you. Now next step, okay, so we can take it as a raised to f of x. So what is the derivative of a raised to f of x? Is a raised to f of x will be 5 raised to sine cube x plus 3, okay, done, into log of 5 means log of a. We can use that formula again, put d upon dx of sine cube x plus 3. Okay, so what is the derivative of sine cube x? So everybody knows that sine cube x, I would like to write it first, plus 3, done, log of 5, done. What is the derivative of sine cube x? It will be 3 sine square x into derivative of okay, into plus the derivative of 3 will be 0. So I am not writing it directly, we can put the value. Again the derivative of sine x will be cos x. Hope you are getting it. So that's the final answer for our question. So what is the final answer? Dy upon dx is equal to this much only. So that's how we can get. Okay, so I have did it right like this. So what is the derivative of this? Derivative of this will be f of x cube. So that is what? 3f square f of x square. Okay, again what is the derivative of sin x? That will be the cos x. So what's over the 3? So 3 is derivative of this, 3 is 0. So I am directly putting the chain rule within the brackets. Let's see our answer is correct or not. Yes, of course it is correct. Now next step, now move to, this is what? Dy upon dx. Okay, so that's how we need to separate it. So please arrange this quantity properly, okay, every time. So use those brackets step by step. As you can see, within the 3 steps we can solve this problem. Okay, we need to have that much practice up to the end of our 12th standard, and most importantly up to the JEE exam. Don't know what will happen to the JEE mains exam. There might be chances of postponing the JEE mains, okay, of Jan 2021. So up to that point we need to practice so many different problems. So I will definitely provide few extra problems also. So please join with us, and if you didn't subscribe our channel, please do subscribe our channel and share with your friends also. If you like these videos and if you feel these videos are helpful while studying within the lockdown, Okay. Now let's move to question number 7. 7th is also quite similar to this. I am giving each and every question's answer, but again the question number 7 is quite easy. What is that question number? Cosec under root of cos x. You can see how exactly this is easy and how much it is easy. So cosec under root of cos x. Okay, very interesting. Differentiation is always easy, okay, as compared to integration. Those who have learned integration in 11th standard by somehow physics and all those chapters, okay, so initial chapters we included that topic of integration. So differentiation is easy, okay, as compared to integration. So in differentiation the function is given, you need to simply apply the rules. But in case of integration, what is the most difficult part is we need to identify that exactly whose derivative is that given function. Listen carefully, whose derivative is that given function that we need to integrate. We need to think about it quite seriously, otherwise we will mess around this integration part. Okay, so differentiation is easy, okay, as we says, okay, making the pieces is easy, but joining those pieces accurately as they were initially, okay, that is what most difficult and most probably what we can say impossible. Okay, so look at it properly, it looks easy. So d upon dx of y, differentiating both sides with respect to x, but you will get d upon dx of cosec of under root of cos x. Okay, so what is the derivative of cosec? Cosec derivative is nothing but minus cosec what? Under root of cos x, okay, into cot of under root of cos x. Okay, up to this part is looks everything fine. Now next step, what is the, again we need to multiply the derivative of what? Cosec x under root of cos x, derivative we need to find out. So what is the derivative of under root of cos x? Is nothing but, again this is another under root of f of x. So we had that special three formulas as I told in earlier lecture, that under root of cos x is nothing but cot under root of cos x into, I need to erase this side little bit. Okay, the next step, what is the derivative of this? 1 upon 2 under root of cos x. Which formula I am applying? I am applying under root of f of x. Okay, so d upon dx of under root of f of x will be equal to 1 upon 2 under root of f of x dot d upon dx of f of x. So using this formula we can solve. Again here the derivative of dx of what is the derivative of cos x? Okay, anybody? So cos x derivative is nothing but sin x. So simply sin x into cosec x. Okay, not that much easy. So minus cosec what? Under root of cos x, done, dot cot under root of cos x, done. Next part, 1 upon 2 under root of cos x, done. What is the derivative of this? Will be minus sin x. Okay, so take that sign minus common, so minus minus, all these things are in multiplication, so that will convert to plus. So dy upon dx is equal to how much? Dy upon dx is equal to how much? So cosec under root of cos x into cot under root of cos x into sin x, whole thing systematically divided by 2 under root of cos x. Okay, so as I told you, this problem is quite easy, but it looks easy, but it's not easy. Okay, now let's move to the next question. Just look at it properly before I erase it. Now these are the steps we need to follow while solving these questions. Okay, there are no tricks, there is no shortcut. Okay, just the shortcut is what you need to practice properly. Okay, good. Now next step. I used to speak so many things within this lecture. Okay, I would like to speak so many things. So you used to communicate within this kind of lectures of 12th standard and 11th standard. We have different kind of discussions while solving the problems. But due to this online procedure, we cannot speak all those terms because it's depending on the two-way communication. It's not. I'm doing only one-way communication, so it's hard to understand how exactly people are reacting to this kind of steps. But still, as much as possible, I am putting each and every step within these questions. Okay, if you want to solve this kind of steps directly, okay, just practice it. Okay, and most importantly, from last lectures I am telling you this thing, try to make questions. Okay, try to prepare your own questions. Means what? Try to make questions. So if I have a function like this, how I can differentiate it? If I have a function like this, how I can differentiate it? So different questions you can arrange. So make functions. Okay, so for example, if this is a cosec under root of cos x, I can make tan under root of sec x. If I want to find out what is the derivative of this, I can make. This is the one of good questions. If I put any kind of formula, okay, again I can make different question. Okay, so that was related to cos x. Now I can make sec x under root of sin x. That is also possible. Now what is the another pattern for preparing the question? Is cot under root of sin x plus 1. This is also possible. Again, sin under root of tan x. That is also possible. As you can see, okay, within this pattern we can make 4 different questions. Okay, so that's not difficult part to prepare this kind of questions. So if you start making your own questions and try to find out their differentiation, that would be better for you and for your point of view regarding this kind of questions. Okay, so simply whenever we want to solve something or we want to make puzzle easy, at that time we need to put some our own puzzles within this puzzle. If this is the case, then what should we do? So in that manner we can solve the questions easily. Now let's move to the next question. What is that? Log of bracket cos x cube minus 5. So question number 8. Okay, so if I write it from here only, so that would be better. Okay, so I will write it from here only, so I don't need to waste this whole ink. Okay, that is also the another case. Everybody is at home and they are solving the questions. Okay, they are studying properly. That's what we can expect from this society, and everybody is safe. So don't make yourself fool. Please don't come out of your home. Please stay at home and be safe. So cos x cube minus 5. Okay, so that's what the required case is. Now this question, what is regards to this? So again, differentiating both sides, we will get again log of cos x cube minus 5. Okay, so easy part. Okay, now again derivative of log of f of x will be 1 upon f of x, means what? Cos x cube minus 5, and derivative of what? D upon dx of f of x, means what? Cos x cube minus 5. Again we need to find out the derivative of cos. So what is the derivative of cos? Sine. So minus sine. So minus sine, I am taking directly to this point, sine x cube minus 5 divided by cos x cube minus 5. Very interesting. Into d upon dx of x cube minus 5. Okay, up to this point is certain things are possible. Now next step, what is this? This is nothing but minus tan of x cube minus 5. Hope you understood it. Now what is the derivative of x cube minus 5? That will be 3x square. That's it. Again rearranging the things, we can get the answer, which is equal to what? Minus 3x square tan x cube minus 5. Wow. Okay, let's check our answer is correct or not. Yes, it is correct. Now as you can see, these questions are easy, so I would like to move further, and they have given us another pattern. Okay, tan of cos of sine of x. Once you again differentiate it, we will get the answer again. Sec of tan of x square x raised to 4 plus 4. That question is also easy, so I am directly moving to question number 13th. Okay, so I am leaving few questions. Okay, no. So one question is missing. This question number is what? This question number is 10th. 9th question I am missing. No? No, correct. Now I need to perform the 9th question also. This was only 8th. Yes, this was 8th. Now what's about the 9th? 9th question is interesting. So 9th question out of question number 2 is like e raised to 3 sine square x minus 2 cos square x. Okay, so let y is equal to e raised to 2 sine square x minus 2 cos square x. Hope I am correct. Yeah, 3 is 3. Okay, now differentiating both sides, again same statement. Differentiating both sides with respect to x. What we will get? Differentiating both sides with respect to x, we have some interesting quantity. What is that? dy upon dx is equal to d upon dx of e raised to 3 sine square x. Okay, in power only 2 cos square x. Okay, hope you are getting. I am putting the bracket to this power of e. Okay, now this e I like most, this e, natural e. So what is the derivative for, what is the differentiation formula for the e raised to f of x? Is nothing but e raised to what? F of x means what here? 3 sine square x minus 2 cos square x. Okay, that's it. Dot differentiation of 3 sine square x minus 2 cos square x. Okay, okay. Now next step. What is that next step? We need to focus at that point. So up to this step is good. Now e raised to 3 sine square x dot 2 minus, not dot, minus 2 cos square x complete dot. What is the derivative of this? This will be like sine square x derivative is nothing but fast 3 sine x dot cos x. Okay, good. What is the derivative of cos square x? Is nothing but, what is the derivative of cos square x? Okay, so this will be here 6. Here will be 4 cos x. 4 cos x minus, sorry, into sin x. Okay, kind of lengthy. Now next comes to this point, otherwise I would like to write it over here. So this is what? 3 sine square x derivative is what? 3 into 2 into sin x into, what is the derivative of sin x? Is nothing but cos x. I am doing it directly, minus, what is the derivative of this? 4. So all these parameters in bracket. This part is not included in video, that's why I am taking at this side. So this again 2 cos x minus, sorry, minus sin x, bracket close. Again simplifying the whole term, we will get e raised to 3 into sin square x minus 2 cos square x, bracket complete dot. What? 6. What is the sin x cos x? So this is 2. Again this is also 2. So this will be like 3 into the 2 sin is cos x is always nothing but sin 2x. Again this minus minus plus, so plus 2 sin 2x. Okay, so simplify it. What you will get? 3 plus this 5 sin 2x, 5 sin 2x into e raised to how much? E raised to 3 sin square x minus 2 cos square x. Okay, I was hiding all this formula. Just look at it properly. How exactly we can achieve this? Okay, I am doing these steps. Okay, directly. So hope you don't have any kind of problem within these steps. Okay, now I know that you are that mature now up to this point. Okay, everything is good. So this is our final answer. Just check it once. Yes, it is correct. Now next move to next problem. Now what is our next problem? Cos square of log of x square plus 7. Now this problem is also easy but quite lengthy. Okay, so I would like to solve it again through here. Okay, so let's move. We don't have time to discuss all these things. What we need to do, we need to focus. So we need to focus such that for short interval of time we need to achieve so many things. So this is what problem number 10th. Problem number 10th, okay, is cos square of log of x square. Cos square of log of x square plus 7. Very very interesting. Now this is differentiating on both sides. You will get cos of log of x square plus 7. Now therefore, what is this derivative of cos square? Means f of x square is nothing but 2. F of x means what? Cos of log of x square plus 7. So smart. Next step. Dot. What is the log of? What is the derivative of log? X. So log of x square plus 7. Okay. I can do it proper directly, but I am doing it for you. So 2. Again, what is the derivative of log? 1 upon something something. So cos of log of x square plus 7 bracket completes divided by 1 upon x square plus 7. Okay, done. Dot into what is the derivative of x square plus 7 is nothing but 2x. Okay, that's it. That's our final answer is. So 4x cos of, oops, one big mistake. What is that? It should not be like this. Okay, we are doing so many different or improper things. So here should be cos of, again, log of x square plus 7. As you can see how it is confusing. So minus sine of log of x square plus 7. So if you are in hurry, how you can do mistakes, you can see. So just look at this. One step is remaining within this step. What is that? D upon dx of log of x square plus 7. Okay, now what is that? Final answer. Okay, I would like to move directly to final answer. So minus cos of log of x. Okay, that's these two have again important property. So sine of 2 log of x square plus 7. Okay. Minus into what is the derivative of this? Remains what? X square plus 7. So d upon dx of x square plus 7, which again can be finally, we can write what? Minus sine of 2 log of x square plus 7 bracket completes divided by how much? X square plus 7. Okay, what is the derivative of x square plus 7? Is nothing but 2x. Okay, that's it. That's what we required. Okay, so sir, how did you write this question? Write this formula directly. So if I look it properly, so cos sine and into 2 means what? 2 sine of dash dash into cos of dash dash. Okay, means what? X, which is equal to what? Sine 2x. Okay, so using that formula I am writing this directly. Okay, so here my f of x is what? A log of x square plus 7, and here is also log of x square plus 7. So directly we can substitute the values, and over here the 2 log of x square plus 7 we can substitute and use that identity and write this formula. So I did it directly, and again the derivative of log of x. Okay, so log of x is nothing but 1 upon x, so that's x square plus 7 is over here. So I am considering this as the f of x. So this f of x will be here. Again the derivative of f of x will be 2x. Now if we don't have any further differentiation, if you differentiate x, you will get 1. So that's how this chain rule works. Okay, so we solved question number 10th. Okay, so question number 10 has this answer. Now what is the question number 11th? The question number 11th is saying that tan cos sin x, tan of cos of sin x. So if you solve the tan of cos of sin x, what will happen? So these questions are now furthermore easier questions which we will face. Okay, so tan of cos of sin x. Hope you are understanding how exactly we are differentiating. So please try to solve the questions. First of all, solve examples. These questions will not be asked, okay, totally in our exam. Okay, they will put only 2 to 3 questions out of this chapter, and those should again easier. So what is tan of cos of x? So tan of cos of sin x. Hope I am correct. Yes. So within this parameter we need to differentiate it. So what is the differentiation? Differentiating both sides with respect to x. This will give us d upon dx of tan of cos of sin x. Okay. Hope the brackets are okay. Yes, okay. Now what is the derivative of tan x? Is nothing but sec square. What should be sec square? Sec square cos of sin of x. Okay. Okay. Now again the derivative of d upon dx of cos x. Cos x is not cos x, it's actually cos of sin x. Okay. Again when we differentiate it, so sec square of cos of sin of x into what is the cos derivative is nothing but minus of sin x. Okay. Again the derivative of sin x. So what is the derivative of sin x? Sin x having the cos x. Therefore sec square of cos of sin of x into, so minus sign I am taking outside, sin of sin x, sin of sin x into what is the derivative of sin x is cos of x. Very beautifully we are getting this whole solution. So step by step I am differentiating, so you can differentiate. Next step, let's check whether our answer is correct or wrong. So 11th having some interesting parameter, and yes, our answer is right. So finally again the next 12th question is also similar, so I am not following that question. So I would like to solve directly question number 13. Okay, so why I am going to directly question number 13? Because it's having some trickiness. So what is that trickiness? So e raised to log of dash 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 dash. Okay, so let's move to this part. I saw the whole 11th standard book, okay, where we use this logarithmic function. We studied the logarithmic function in chapter of function and relation on sets. So within that parameter I didn't solve one formula. So I would like to give that formula for each and every year. I am giving this formula, and even in past 11th standard book also, means in old syllabus also, they didn't had this formula, they didn't put this formula. So I would like to give you that formula. So let's consider for 13th question, e raised to log of, okay, what should be the log of log x bracket square minus log x square That's how this is very interesting. I would like to give you one hint regarding this parameter. Okay, what is that hint? So whenever we are using e raised to f of x, okay, we don't have any kind of different substitution within this case. But whenever it is like e raised to log of f of x, okay, that would be equal to what? Only f of x. Most important formula which I would like to give you within this task. Okay, why this is most important formula, sir, and how this is important? If you use this formula, definitely your answer, okay, which we can solve by using our initial methods. But if you use your own formula, okay, without using this formula, we will perform this problem, and with using this formula, we will perform this question. Okay, find out the answer. Answer will be same. Okay, so this is the formula which I wanted to introduce you. So it's in front of you. Using this formula, what should be this equation? This equation is like log of x bracket square minus log of x square. Hope, okay, good. Again, one parameter I need to introduce you is always like sine of x bracket square is equal to sine square x. Okay, but log of x square should not be like this. Okay, so this is not proper, this is not defined. Okay, so we are performing log. Log is again taking log of x. Log of any variable x is one of the operation. Again, sine of taking any x is again one of the operation. Okay, so these operations are not in this manner. That's what I wanted to put in front of you. That's how this is different and this is different. Okay, so log of x bracket square again is not equals to log of x square. So please aware of this thing. Most of the students are doing it blindly. What they think, log of this will be 0. So again log of 0 don't know. So they will put it like this, e raised to log of 0. So that might be the possible case. So don't do this kind of mistakes. Okay, that's how this problem is interesting. So as I said, this is equal to something. So I put in front of you all these formulae. I need to erase those formulas for one case because I need to put again this y is equal to something. Hope you got it. Now again we need to differentiate within this case as using the formula. What was that formula? Since e raised to log of f of x is equal to f of x. Okay, this formula I am using. So what is that f of x? Log x square minus log of x square. Okay, now let's differentiate it. So log of x square derivative will be d upon dx of log of x bracket square minus d upon dx of log of x square. Okay, now next step, what is the derivative of this? This will be 2 log of x. Okay, that's it. Dot d upon dx of log of x minus, what is the derivative of this? This will be simply 1 upon x square. Again the derivative of d upon dx of x square. Okay, hope you will get it. Next step, okay, so step by step. So what is this? 2 into log of x. What is the derivative of this? X only. So log of x derivative is x, and again x derivative will be 1. So no need to write it. So I am directly writing 1 upon x minus, what should be this derivative? So this will be equal to minus 2x upon x square. So this x and this x square will get cancelled. So our final answer will be like this: 2 log of x upon x minus 2 upon x. Okay, so which is having the same base, and therefore we are getting our final answer like this. What is that? Take 2 common, or we can have it in power also. So log of x square minus 2 divided by x. Just check whether we are correct or wrong. Yes, we are correct. So this is the final answer they are putting, but I am again simplifying this answer. Okay, so if you use this formula, your answer will be like this. Okay, just look at it properly. So final answer of this will be equal to dy upon dx. Okay, hope you all are following this formula. I don't know how many of you know this formula. If you don't know, just note it down. This is quite useful formula, and we will use it throughout this calculus part. Okay, so that's a very useful formula. Next step, without using that formula, how we can differentiate it, sir? Okay, so we did it by using this formula. Now without using that formula, what we need to do, we need to simply perform our differentiation as we used to do. Okay, so let's check whether our answer will correct or not. Will be equal to this. We don't have any kind of mess, but whatever the mess that given by them, we need to simplify them. So that's why I am using that formula. Now just focus. So e raised to log x bracket square minus log of x square. Okay, yes, correct. Now what is the derivative of e raised to x? Is nothing but e raised to x only. E raised to log x bracket square minus log x square. Okay, dot. Okay, again the derivative of this whole term. So what is the derivative? D upon dx of log x bracket square minus log x square, log of x square. So hope I am clear up to that point. Yes, I am correct. Next, log x bracket square minus log x square. Again, what is the derivative of this? Will be 1 upon log x 1 upon log x bracket square minus log of x square. Now you can see how complicated it is, but I will make it simple. Dot, so then d upon dx of log of x bracket square minus log of x square. And again we know the derivative of this, but we need to focus on this point also. Okay, so how we can simplify this term? Okay, how we can simplify this term? The simplification of this term will be like this: e raised to what? E raised to x divided by x. Can we simplify that term? So e raised to x divided by x, it should be 1, but it's not equals to 1, and that's how we require this formula. Okay, that can be possible only when we apply this formula. So whatever that, so e raised to f of x raised to log of f of x should be equal to 1. Understood? As you can see over here, this is whole term is what? F of x. Okay, if you compare with that formula and divided by f of x, so e raised to log of f of x divided by f of x should be equal to 1. Okay, now again we need to differentiate it. So we initially differentiated it and we had the answer like this. So e raised to log x bracket square minus log of x square, okay, divided by log of x bracket square minus log of x square. Okay, follow me. What should be its derivative? Is again what? 2 log of x divided by x minus, I will put it in bracket, divided by, again what is the derivative of log x square? So it's nothing but 2 upon x. Okay, so 2 upon x. That's how we are proceeding. So this was our derivative of this initial term. We had already derived it. But what's about this, sir? Okay, this should be equal to 1 and this should be equal to 1 and only 1 when this using this formula. Okay, using this formula, what is that? F of x divided by f of x, because this is equal to f of x as per this formula. So that's how we can have this equals to 1. Okay, this whole formula equals to 1 into this our formula, and that's how we can compare our answer. So if you don't use this formula, you will have this complication. So we need to use this formula on the basis of this, and that's how this problem was interesting, and we are giving this solution to you. Now again, the most important parameter which I would like to introduce. Question number 13, quite easy. Question number 13 was done by me right now in front of you. We have, and this is equal to 1. Okay, so the final answer will be this much only. So 1 into 2 log of x divided by x minus 2 upon x. Okay, that's it. Now next step is what? If you have this in your mind, okay, so this up to this problem, we can see these problems are not that easy as we saw them. Now same question is in front of you, the question number 14. The question number 14 looks easy. Again we had this under root case, so we need to again simplify that case, and again we need to substitute few quantities. Now let's do it. Okay, so within this part 1 of exercise 1.1 we will solve these terms, and after in part 2 I will give the remaining questions. So from question number 3 to question number how much? Question number 7, hope so. Okay, question number 8. So question number 3 to question number 8 we need to make video 2. So up to this question we will make one video. Question number 2, the part 1 is done. Okay, now let's move to question number 14. Okay, the question number 14 says that the sine of x under root of sine under root of x. So sine under root of sine under root of x. Quite interesting question. Again, it has some its own property. Hope you like this question and its solution also. Okay, so I would like to erase it. This formula is quite important. Please do not forget this formula. Okay. Hope you are enjoying this session. Don't know how many of you use this formula and how many of you are solving this problem by your own. Okay. So this also has nothing to do with this problem. So under root of sine of under root of x. So if you differentiate, what is the derivative of sine x? Is nothing but cos of under root of sine under root of x. Okay, done. Now derivative of dx of sine under root of x bracket raised to 1 by 2. So I will not put that under root 2. But what is this? This simple case. So what is the derivative of under root of sine? So is nothing but, so under root of f of x is nothing but cos under root of sine under root of x divided by 2 times under root of sine under root of x. Very interesting. Now next step, derivative of d upon dx of under root sine x is done. Now sine of under root of x. Okay, again next time we need to find out the derivative of d upon dx of under root of x. Okay, so I am directly writing this formula. Now next step, what is the derivative of sine under root of x? That is nothing but again cos under root x. So cos of under root of sine under root of x into cos under root of x divided by again this parameter, that is again 1 upon under root of x, 1 upon 2 under root of x. So therefore it will be 4 under root of x under root of sine under root of x. Hope so I am clear with this question. So question number 14 has the same solution. Now I can do it thoroughly. Okay, I can do it thoroughly if I understood in exact which manner I am differentiating. Okay, so it's quite simple again. So how I can do it in this manner? So I would like to introduce another thing, d upon dx of f of g of h of x. Okay, so as many times I am using this one, yes correct. So So this is for this is for this is correct. Now I need to find out the derivative of x of f of g of h of x first, then again d upon dx of g of h of x into d upon dx of h of x. Understood? So in this manner I can perform the differentiation, and that's what the chain rule is about. Okay, so simply I am doing that thing only. Now next move to next question. What is that next question? Question number 14th done. 15th. Question number 15th. So I didn't write it over here. Question number 14th was done. Now next step we need to move for question number 15th. To question number 15th I would like to write it here. So let y is equal to, what is that? Log of sec of e raised to x square. Not difficult, quite easy. Look at it properly. Differentiating both sides with respect to x. What will happen? So d upon dx of y is equal to, again, d upon dx of log of sec of e raised to x square. Okay, up to this point good. Now next step, what we need to use? We need to use another factor. Now what is the derivative of log of sec e raised to x square? Is nothing but 1 upon sec e raised to x square. Okay, done. Next step, what we need to differentiate? Differentiating sec e raised to x square. So dx sec e raised to x square. Again differentiating this parameter, you will get 1 upon what? What is the derivative of this? This is nothing but sec e raised to x square into tan e raised to x square divided by sec e raised to x square, okay, dot d upon dx of e raised to x square. Hope up to this point is clear. So this is the above numerator is nothing but the derivative of sec e raised to x square, and again the denominator which we got from the derivative of the log. Again we need to differentiate e raised to x square. Okay, so quite outstanding. Next step, here we need to introduce it. So I will erase this step over here. So we will get the question number 15, which is different from the initial problems. So what is the dy upon dx of 15? So dy upon dx of 15th question was sec square e raised to x square will get cancelled. It remains what? Tan e raised to x square, bracket complete, divided by nothing. So divided by 1 into, what is the derivative of e raised to x? F of x is nothing but e raised to f of x, means what? X square dot derivative of d upon dx of x square. So which is equal to 2x tan e raised to x square into e raised to x square. That's it. That's what our final answer is about. Yes, and which is correct. So within these steps we are getting dy upon dx of question number 15. Okay. Now next question. What is our next question says? Next question says something like this. So again the log of this done. Question number 16 is important. I would like to make attention for this question because it contains e square term. So log of x base to e square. That's what the complicated problem is. So question number 16 something like let y is equal to log of x base to e square. Most of the students are afraid of this thing. Okay, what is this e square base? What we need to do, sir? Okay, you don't need to be special regarding this. What we need to do, we need to simply put the mathematics or the mathematics of logarithm. So differentiating both sides first, both sides with respect to x, what you will get? Dy upon dx is equal to d upon dx. What is this? D upon dx of this. Okay, so here is something base concept. So as I had in earlier problem, in this earlier lecture, I told you regarding these formulas. What are those formulas, sir? So we have this formula for log of x. Okay, log of f of x. What is that formula? That formula was like this. If you are differentiating what this formula, okay, I will put it over here. So d upon dx of log of f of x, okay, which is equal to 1 upon f of x dot f dash of x. Okay, this was very easy concept. Now what's about, sir, d upon dx of log of f of x base to a. So it was nothing but f dash of x divided by f of x into log of a. Hope you remember this. Okay, so we need to apply this formula over here. So what will happen, sir? Okay, so simply we can differentiate log x base to e square. That's it. So simply apply this formula. Okay, and we will find the answer. So what is that? What is the log of f of x? Is nothing but 1 upon log x. So 1 upon log x. Okay, what is f dash of x? So this is nothing but f dash of x. That is what? 1 upon x. Again into 1 upon log e square. Okay, everything is good up to this point. Now next step, which is 1 upon log of x into log of x into log of e square. That should be our final answer. Just check it once whether we are correct or not. Okay, now sir, we solve this up to this problem. Okay, so what to do with e square? Okay, so we need to perform this. Okay, just note down this formula. I would like to again substitute this above. So this formula is correct, everything is correct. Up this step we are correct. Now, so this is not the given answer. What should we do? So we need to have our fundamentals with us like this. So this says something like 1 upon x into log of 2 times log of e. Hope you understood. Okay, so this is nothing but this log of e square. So whenever that is log of a or b or c, something like this, log of x square, it can be like 2 log of x. So similarly I am using this e over here, and 2 is common, and what is log of e is 1, log of e is 1, therefore this will convert to this. So x into log of, sorry, it should be here x, again x, and log of e will be 1 in multiplication. So therefore dy upon dx of the question was 1 upon 2 x log of x, and that's how we are correct. Now the next questions are easy. I would like to solve question number 17. Okay, let's move to question number 17. Question number 17 is again quite lengthy. Hope you got this answer of question number 16. Question number 17 of question 2 of exercise, from exercise 1.1 will be like this. What is that? Within 2 minutes can we solve it? Question number 17. Let y is equal to log of what? Again log of x bracket square. Hope so I'm correct. Yeah, no, not correct. The whole bracket square is there. Okay, so whole bracket square. So again differentiating both sides, what you will get? Dy upon dx. Let me do one magic. So 2 upon log of okay x. Okay, again what is the derivative of this? Will be log of x. Okay, up to this step is good. Now what is the derivative of log x? Is nothing but 1 upon x log of x, and that should be our final answer. Okay, that's how we are getting the final answer. So 2 log of log x divided by x log of x into log x. Very interesting. Just check whether our answer is correct or wrong. Okay, I did it in hurry. Hope so I am correct, and that's how I'm correct. Why sir and how sir you are getting this answer? Because I am directly substituting this value and somehow I can achieve that thing, but just with respect to x. Okay, so up to this point, so most of you are thinking like, how did you solve this question? So this question is quite easy. Again, all those thoroughly I solved it step by step. Okay, so just if you look at this properly, or if you want to solve it again, okay, I can solve it. So look at the steps. Okay, how we need to solve them. What I wanted to tell you is that if you practice very well, you can easily find out the solutions on your own. Okay, take any kind of equations, but for initial days we need to solve them step by step. Log of x bracket whole bracket square. This is f of x square. So 2 log of x. Okay, done. And again at this side we need to differentiate one quantity d upon dx of log of x. Okay, so on that basis, if you take the differentiation of the log of this whole function, it will be 1 upon x. So that 2 log of x, okay, divided by what? This 1 upon log x. Okay, next d upon dx of this log x will be equal to what? 2 upon log of x divided by log of x. Okay, now next step, this log x will be again log of x. Next step, what is the derivative of d upon dx of log x, which is nothing but 1 upon x. So our final answer will be equal to what? 2 log of x divided by here x into log of x into log of x. Okay, so this bracket is separate, so due to which we can get our answer properly. Okay, up to this point everything looks fine. Now what I wanted to suggest you, okay, do it on your own, this kind of problems, and you can make your own problems. Okay, now I would like to leave the question number 18 for you for practice purpose, and up to this video we will continue. We had this question number 2 only of this exercise 1.1. So within this lecture we solve the problem which we can solve step by step. Okay, and those were important, and by using, we solved this problem by using our chain rule, simple chain rule. And now in next lecture we will prepare the question number 3 to question number 8. Now if you have any query regarding these problems, so please let me know. Write in comment section whether if you like it or whatever the mistakes are there. If you like it, please share with your friends, subscribe our channel and hit the bell icon so you can get the next videos update. Thank you.